All of us know mathematics is a very important and useful subject for all the children, even for visually impaired. According to the National Council of Teachers of Mathematics, that is NCTM, all students need meaningful mathematics with appropriate tools. It is particularly important for students with visual impairments to be exposed to the use of multiple mathematics strategies and tools, including use of the abacus, Taylor frame, braille writer, geoboard, mental mathematics, talking calculators. These strategies and tools should be introduced early in child's educational program and continually reinforced throughout the school years. In this chapter, the following mathematical aids are discussed below. 1. Abacus. 2. Taylor frame. 3. Geometric kit. First we will see abacus. Abacus is a device used by visually impaired children for doing basic mathematical calculations. Abacus is rectangular in shape. Abacuses or abaxi, that is the plural form of the term, with varied columns are used in different countries. For visually impaired children, abacus with 15 columns is generally used. A bar is separating the abacus horizontally, cutting across all the 15 columns, leaving 2/3 of the area below and 1/3 of the area above of it. The lower portion is known as lower abacus and the upper portion is known as upper abacus. Each column in the lower abacus has 4 beads. Each bead assumes the value 1. Each column in the upper abacus has 1 bead and assumes the value 5. In operation, the extreme right column is treated as the unit column, the immediate left to the unit column is the tens column, and so on. Setting. The process of moving a bead of the lower abacus or the upper abacus towards the separation bar is called setting. Clearing. The process of moving a bead away from the separation bar either towards the top of the upper abacus or the bottom of the lower abacus is called clearing. Example for complement of a number with respect to the given number. For example, take the number 6. The complement of this number with respect to the number 10 is 4. Hence, complement is the value which completes, that is, the remaining value with respect to the number which completes. The complement of the number 6 with respect to the number 100 is 94. The complement of the number 6 with respect to 1000 is 994, and so on. Dots of the separation bar. The dots are helpful for locating the place value of the number in abacus. These dots determine the locations such as whole number, numerator when fractions are presented in the abacus. These dots may not be present in some abacuses which have 13 columns. In such cases, imaginary dots have to be assumed for placing the numerator, denominator and whole number in the abacus. This does not envisage any change in the procedures in operation. Example, 82 minus 19. First, set the number 8 of the 82 in the tens column. 2. Set the number 2 of the 82 in the units column. Now, right and left hands should be on the units and tens column separatively. In this example, we have to clear 1 in the tens column and 9 in the units column. Clear 1 bead in the tens column since the units column has only a value 2. It will not be possible to clear 9 in that column. With the help of your left hand, clear 1 bead in the tens column. To compensate this excess in clearing, add 1 bead in the units column, that is, add 1 bead with the already available 2 beads. The answer is 63. Next, we will see what are the prerequisite skills for the efficient learning of abacus. Position of the abacus is very important. Then position of the beads, structure of the abacus, that is upper abacus, lower abacus, separation bar and working space. Holding the abacus, avoiding unnecessary fingering. Thumb should move the lower beads and the 4 fingers should move the upper beats. Supplement and complement values must be tough. Value of the upper beats and lower beats must be understood. Right and left concept must be known. Memory of the multiplication tables for numbers 1 to 20. Memory of the squares of the numbers 1 to 25. Memory of the square roots, that is perfect of squares from 1 to 1000. Understanding the relation between the fraction, division and fraction multiplication. Next, we will see what are the principles of teaching abacus. While teaching abacus, we should remember the principles like familiarize the students to the abacus before starting to teach mathematics. Have him to count the beads and practice moving them. Be patient and introduce each step slowly. Do one step at a time. Start the next one when the first is definitely accomplished. Keep language of instruction simple and consistent. See that the student maintains a proper hand position. Be sure that you know how to do the problem and have not accidentally given a student a problem that issues a function that he has not been taught. Make sure that the child is solving simple mathematical problems on the abacus and not on the hand. Next we'll see strengths of an abacus. Some of the main strengths of the abacus are apply to manipulate it very quickly, proper placing of numbers, ability to solve addition, subtraction, multiplication and division problems, solving problems having many digits, even up to 10 digits, solve problems involving fractions or decimals, solve problems involving square roots and percentages. Some of the weakness of an abacus: unable to solve problems involving linear equations or geometry, algebra or trigonometry graphs. The steps in a problem cannot be displayed. Only the final answer can be viewed. Next important mathematical aid is Taylor frame. The Taylor frame is a well-established device that provides a complete tactile solution for the visually impaired to learn mathematics. The Taylor frame consists of a large flat plate carrying several rows of octagonal holes. Rectangular rod-like inserts are provided. One insert can be placed in each octagonal hole in one of the 8 directional positions. One or both ends of the inserts are inscribed with one of the 4 standard raised shapes that can be identified by touch. The 4 shapes and the 8 directions in which they can be positioned make for a total of 32 combinations which are assigned uniquely to numerals, mathematical symbols and operators. A sequence of shapes on a sequence of inserts so placed can thus represent a number of mathematical expression. Inserts on the first row of the frame can be represent the first number, and insert on the second row can represent an arithmetic operator followed by the second number. The third row can be carry the result of the arithmetic operation, while remaining rows can be used to hold a remainder or carry over or other temporary values during calculations. This design is intended to be adequate for an initial learning load of the young child of establishing shape and direction, identification and use of simple addition, subtraction, multiplication and division of 1, 2 or even 3-digit numbers. Once these skills are mastered, the child should be ready to move on the higher skill with larger computations on the rectangular larger standard Taylor frame. The 4 standard shapes and their 8 directional orientations with the symbols, values or operators that each shape or direction combination represents the different values. First we will see the symbols used in Taylor frame: arithmetic symbols, the algebraic symbols, the 2 flatter type and triangle shaped pegs are algebraic symbols. These also This algebraic symbols also having 16 positions. Next we will see some of the strength of a Taylor frame. The strength of the Taylor frame are as follows. Steps can be displayed. Each and every step can be visible. Then ability to solve addition, subtraction, multiplication and division problems. Ability to solve problems involving fractions and decimals. Ability to solve percentage and square root problems. Ability to use various brackets involving problems in simplification methods. Ability to solve algebraic problems. Pegs have different shapes to identify the position of various notations easily. Since it is like a pegboard, we can also frame geometrical and graphical shapes. Ability to do the rough work. Like cited method of doing problems, we can do it by using Taylor frame. Some of the weakness of a Taylor frame. The weakness of a Taylor frame are in metal Taylor frame, the pegs are made up of lead, which is poisonous. It is time consuming. The third important mathematical device is geometric kit. Under that we will see first geoboard. Geo is short for geometric. Geoboards are boards of wood or masonite with nails placed at rectangular intervals, much like a pegboard. Some have line segments like grids displayed while others do not. Line segments, shapes or other designs can be made by arranging rubber bands or string or other appropriate materials. Numerous games and activities can be carried out on a geoboard to teach such concepts as shapes, positional concepts in 2 dimensions, patterns, area, perimeter and fractions. Let us see the general concept about the tool. It is a multi-purpose board. This can be used for showing geometrical figures and graphs. It is a pegboard, square or rectangle in shape with nails at equal distance, both lengthwise and breadthwise. The distance between the nails can be determined according to the levels of the students. This geoboard is a wonderful companion for the visually disabled children, especially in the teaching of mathematical concepts. Geoboard will introduce children to a host of new terms and concepts, but they will probably be too busy exploring and discovering to notice they are learning. This activity helps children discover shapes, angles, lines, patterns and other geometric and mathematical concepts. Children will love putting their imaginations to work creating shapes with the rubber bands or strings. Intelligence that will be enhanced. Fine and gross motor skills, visual motor skills, visual and auditory memory, figure and shape perception, spatial concepts and relationships, directionality, concepts of diagonal lines. Uses of geoboard. Use various sizes and colors of rubber bands to make patterns on the boards. Ample time should be given for experimentation and exploration of possibilities. Make a picture on the geoboard, copy someone's shapes, follow the verbal instructions of the teacher or another classmate to draw a design on a paper, grid and then make it on the board. Label points on the geoboard using letters of the alphabets or numbers. Use these points to give directions for a design. Demonstrate spatial concepts such as inside, outside, between, under, over, parallel, right, angle, diagonal, horizontal, vertical. Geometric figures. Triangle, square, rectangle, parallelogram, pentagon, hexagon, octagon, polygon. Angles. Right, acute, obtuse. Areas of geometric figures. Using different size of squares and then triangles. Find the area of square or triangle. Find areas of variety of closed geometric figure. Develop a rule for finding the area of a triangle. Terminology, base, height, area. Make a data chart of various triangles, their base, heights and areas. Tactile displays. Tactile diagrams translate images into a tactile language. They are not exact relief reproductions of visual images. Tactile diagrams allow people to access the visual information in works of arts, maps, diagrams, and three-dimensional objects. Learning to read tactile diagrams is essential for visually impaired students since it strengthens the skills necessary to read tactile maps, mathematical diagrams, geometrical and graphs. Talking calculator. It is an audible calculator with a synthesized speech output. Talking calculators may be used in educational settings in a variety of ways to practice basic facts to improve the speed and accuracy of computational skills. To provide students who have mastered basic operations with a competitive calculation tool to provide an alternative to the Abacus for advanced mathematical calculations that are too complex for computation with the Braille writer to solve problems which are challenging and interesting. The geometry set and drawing tool. Visually impaired persons should be taught to use the drawing tool to emboss dotted lines on the plain paper, which can be sensed by touch. They should then be taught to draw straight or curved lines along the edges of the ruler or set squares or the protractor to represent lines, angles, and curves. Teaching has to be innovative and imaginative to enable the learner to understand the concepts of shape, size, measurement of length and angles, and calculation of area, volume. Geometry mat, spur wheel, and compass set. A sheet of rubber for use as a base in conjunction with a spur wheel and braille paper or relief sheets for making geometrical drawings. Spur wheel is a scratched wheel resolving in a plated metal handle. It is used for making continuous embossed lines on the reverse side of the paper or relief sheets. Compass set including a foot ruler, a protractor, and a set square in nylon and a spur wheel. It enables visually impaired students to use the same techniques as their sighted counterparts. The foot ruler and set square have embossed markings for the convenience of the visually impaired students. The compass has a removable component fitted with a toothed wheel for drawing embossed dot lines on the reverse of the braille paper or relief sheets. The development of the technology has made impossible things possible both the teacher and the student. In the education of the visually impaired, the technological growth invaded and equipments like talking calculators, computer assisted instruction, and other mathematical aids have already challenged so-called impossibilities in mathematics. The latest equipments with effective teaching approach of the teacher not only make the learning possible but open fresh avenues for larger developments. Experience all over the world has revealed mathematics, and the one thing the educational system should do is to provide them to the right opportunities. In short, with proper material, with good resource, regular teacher cooperation, and with a thorough follow-up of the learning, mathematics could be made possible and easier for visually impaired children.